Welcome back to the final course in this series, where we've learned how to put a label on the screen, to putting that label inside of a grid with a bunch of other things on the screen, to making scrolling lists of collection views and refresh views, and even some MVVM. The last thing I want to share with you is how would this all look using XAML for our UI instead of C#. So if you missed it, make sure to go back and see the previous video on XAML where we introduce a lot of the basic concepts around it. Because in this video, we're going to dive a little deeper into XAML. So make sure you're caught up first, but let's jump into it. So the first thing I'm going to do, I'm just going to rename our existing files because I'm going to cheat. I'm going to reference the C# code we already wrote to write the XAML code that we need to write. But I'm going to not change anything else. Just we'll change this to details page C#, and I'll change my class name to the same because we're just going to create a XAML page called details page. And you'll see in a second, it'll just work. All right, so let's go ahead and say add a new content page. We'll call it details page. And let's bring it over to this side so we can work on both side by side. And what we see here is our new details page, but we want this details page to use our base view model. So there's a couple things we got to do right away, right? This is the fun of working in XAML, and if I'm being honest, why I do my UIs in C# instead, is because of things like this XAML namespace. So XAML namespace, we'll call it page. This has to be our XAML namespace. Now this will be called Hello Maui, and it'll be the Hello Maui namespace. And that means now we can say Hello Maui base content page. And then the other thing that was just added for us is this X type arguments. So it needs to know what type our view model is. And let's see, can I just paste this in? Nope, of course not, because it's XAML. It's going to be Hello Maui : thought that would work for sure. Oh, because it's in a different view model class. Okay. All right, let's do a couple things. First of all, I'm getting yelled at because this is capital H. So let's make that a lowercase h. And then what we need is another namespace because our view models live in the Hello Maui.viewModels namespace. So this will be our XML namespace so we can reference our view models. And look at that. Now it's happy. So we're referencing base content page now for our Hello Maui pages details page. And actually, I see our pages didn't use a different namespace. So let's make sure to keep that aligned. All right. Let's start building some UI. Now, what do we see? I see a vertical stack layout. So for our content, just like we did in our previous XAML video, we'll create a vertical stack layout that has a spacing of 12, and then we'll add some images to it, or add some children to it, the first one being an image. So we have our image that, let's see, we want to probably just get away with closing it. So center, we want to horizontal alignment, center, vertical options, center, size being 250. So that's our height request. It's going to be 250. Our width request is 250. And then our binding, this is where it gets interesting. So this is the new part. All of this should feel familiar from our last XAML video. But now what we're going to say is our image source equals, and again, this gets weird, so stick with me. But we do open close curly brackets and we say binding, and then we type in the property we want to bind to. So if I type in library image source, well, this will work. But you can see here, I'm getting yelled at a little bit, and you might have saw things about X data context. And this is something that's fairly new in XAML, but what we can do is come up here and say X data type, I'm sorry. The data type will be our details view model. And look at that. Now you can see that we have IntelliSense recognizing that this is in the details view model and I can see it. And all of that comes around because of something called compiled XAML. So there are some places where XAML will check our code, or rather the compiler will check our XAML code before you run it. But a big thing to keep in mind, and a huge difference between XAML and C# is in C#, everything's compiled ahead of time. So if we were referencing the wrong property, so if I had a typo in image source library here in my XAML, and we didn't give it the data type so the compiler knew which class we're talking about, well, this code would still run, and that's because XAML is interpreted at runtime, whereas C# is all compiled ahead of time. So if we had misspelled this property name in our C# class here, like maybe I forget the E, well, I'll immediately get a red squiggle. I'm going to get yelled at. The app's not going to run because it's not even going to compile. Whereas if I didn't use data type and I forgot the E here, this will compile, this will run. But when the code finally hits this point, it's going to crash. So keep in mind, everything in XAML, most things in XAML are compiled at runtime. It's called just-in-time compilation, but we can get some help by adding this xData type to let the compiler know, the XAML compiler, know that the data type or the data binding for our base content page here, our details page, is going to be details view model, and then it can help us out a little bit. And an xData type can be applied anywhere we want. So I put it here on the content page because that's the binding context for the content page. But I could put it here for the image. If maybe only the image was bound to the details view model, we could put it here. Or we could put it here in the vertical stack layout. That would mean everything in this vertical stack layout would have the same data type. And of course, you could always, just as an example, we won't keep this, but maybe your image is bound to a different view model than the vertical stack layout. You can specify different ones inside. But if you don't, then your XAML compiler will assume every child in this parent class has the same data type. So that's why I put it up here for the class, because I know that everything in our class that we created together has the same binding context of details view model. Now, keep that in mind. That'll come into play when we talk about our collection view in just a minute. But let's finish building out our details page, and then let's go ahead and run it to make sure everything still looks good or looks good enough. In other words, let's make sure all these new bindings we're adding in all work in XAML. Okay, so label, text center. So that means text alignment needs to be centered. Vertical text alignment needs to be centered. There we go. Dot center is the same code up here. Horizontal and vertical options. That makes sure the label's in the center of the screen. The font. So let's see, font family. No, font attributes. Boom. Bold. And we want font size to be 24. And then we want text to be a binding. So again, remember, bindings always start with the open close parentheses. And now that the XAML compiler knows our data type, so our xData type is the data context. So you can see that's a little confusing here, but it kind of makes sense. It makes enough sense that we can overlook it. So our data type, our data context is our details view model. So when I say binding and I point it to library title, and what I'm going to do is copy paste a lot here in XAML because I don't want to have any typos. Because again, a typo in XAML will only be found at runtime unless the XAML compiler is able to catch it. But even the XAML compiler doesn't and can't compile everything in XAML. So you always do run that risk anytime you use XAML for UIs that your app might crash at runtime if you missed a typo somewhere. And that's never fun. Also another reason I usually stick to C#. But if you know XAML, you love XAML, keep using it. It's totally valid. These are all just things to be aware of. Okay, so the next label, text center, font. So it looks pretty similar. I'm just going to copy paste a lot of this. So center. We don't want it to be bold. We actually want it to be italic. And we don't want the size to be 24. We want it to be 16. And something else you'll notice here in XAML, these are all just strings. So in reality, center is an enum. So for example, if I said like vertical options here in C#, it would say layout options.center would be the enum we use. But here in XAML, we just type in the string center, and then XAML knows how to essentially inflate that or hydrate that into C# using the enum layout options.center. So that's another weird thing, is that the XAML doesn't follow the actual C# code one-to-one. I understand why they do this. They try to make our lives a little bit easier so we don't have to say layout options.center every time, but it can be a little confusing, especially when, things like font size, which is an integer value, or actually I think it's a double value, and we're passing in the string 26. So this string 26 is going to be converted into a double, but it is just a string. So if I said font size equals Brandon, I don't see any red squiggles, do you? So this code might actually compile, and of course it would crash at runtime when it tried to convert the string Brandon into a double. But anyways, back to porting this app to XAML. Our text binding is actually going to be our library description. So let's fix that. And then the last thing we'll add is a button on the screen. So the button text, this is one place where putting a string in via XAML does make sense, because text does take in a string property. So we can say text equals back. And then the command is also going to be a binding. So open curly brackets and point it to our handle back button command. And let's see, the last thing I see, our vertical stack layout is centered. So let's come back up here and let's just copy paste some code to save some keystrokes. And then we've also got a padding of 12, which again, if you pass in padding equals the string of 12, that'll apply it everywhere. And you can kind of see here in JetBrains, it gives us a little helper that says, hey, this is going to all of them. So left, right, top, bottom padding. If we said 12, 12, well, again, JetBrains helps us out a little bit. It's going to say this is our horizontal padding, or our left, right padding of 12. Our vertical padding will also be 12. And then if you did it even more, now we can specify top, bottom, left, right. And actually, it doesn't go in that order. It goes in left, top, right, bottom, which again, these little helpers here that you see on my screen might not appear on your screen unless you're using JetBrains Rider. It's another quirk of XAML where everything gets passed into a string. And then there's certain formats that the XAML compiler or XAML interpreter knows how to convert that string into the values it needs, which in this case is a thickness value for the padding. Okay, so we got our vertical stack alignment centered. We got our padding. I see we set our shell back button behavior on iOS specifically. And let's skip that for just a second, because I see another binding up here I don't want to forget about. So our binding on our content page. So even our content page up here, all the way up here, has a title. And that title property can also be a binding. So we'll say this is going to bind to library title. And there we go. So let's go ahead and run this and see how it looks. Whoops. But before we do that, I've got some compiler errors. And that's because I didn't come back in here to properly